is one of the most famous space photographs ever taken. As seen by the Hubble Space Telescope, it shows the pillars of creation, massive columns of dust and gas 7 light-years long. As big as they are, the pillars are just a small part of an immense stellar nursery 6,500 light-years from Earth, called the Eagle Nebula. Nebulas of all kinds are scattered among the stars everywhere and are among the most spectacular sights in ours or any galaxy.
Nebulae are beautiful, all of them. They really strike the eye.
From the Greek word for cloud, nebulas are just that. Clouds of interstellar gas and dust, rarely visible to the naked eye. But with telescopes in space and on Earth, their beauty is revealed. Glowing, reflecting, or obscuring the galaxy's light. They are regions where stars are born, where stars die, and where explosions wreck the very fabric of space-time.
Nebulas have fantastic shapes, like clouds in the sky on a summer day. They often evoke imagery that hits very close to home. Images of flowers, images of insects, images of people.
It's interesting when people look at nebula, it's like a Rorschach test. They sort of start seeing things in it.
Although nebulas are labeled with numbers from astronomical catalogs, many also have names inspired by their locations or shapes. It's not difficult, for instance, to see why this is called the Butterfly Nebula, or this is known as the Horsehead Nebula. The list goes on.
The Orion Nebula, the Ghosthead Nebula, the Stingray Nebula, the Helix Nebula, the Cat's Eye Nebula, the North American Nebula, the Pelican Nebula.
The astonishing forms nebulas take make them the tourist attractions of the galaxy.
If you've got the family on a flying saucer and you're careening through the Milky Way looking for an interesting rest stop, you're going to go to a nebula.
Like tourist attractions on Earth, faraway nebulas entice us for a closer look.
Man, it's a hike.
One of the prime attractions in the night sky is the Great Orion Nebula, one of the very few nebulas you can see with the naked eye. On a clear night, it appears as a fuzzy star in the Sword of Orion, probably the most recognizable constellation in the sky.
The Orion Nebula is the most active area of star formation in our galaxy. It lights up the sky like nothing else. So this is a big one. In terms of nebulas, this is the Hollywood sign.
And the reason why travelers want to get close to tourist attractions is the same as why astronomers want a closer look at nebulas. They each want to take photos. After all, tourism, whether earthly or astronomical, is all about the pictures.
Photographs of nebulas occupy a real special niche, a very important niche, I think, because they really do sit at the pinnacle, the confluence of art and science.
Of course, getting good pictures of a nebula isn't just a matter of point and click. In the mountains north of San Diego, a group of amateur stargazers have an especially tough road to follow in seeking out nebulas and taking great pictures.
It is always worth the long drive to come out here. Night under the stars, even if I don't do any imaging, is worth it, just to see what I can't see from home.
When the equipment is this complex, these enthusiasts aren't just taking pictures. Here, the word is imaging. And their favorite targets are the nebulas.
Just being able to look at them and imagine what's going on out there in that gas cloud, being able to see a sense of where stars are forming, it's just a great kind of a sensory experience to have.
In addition to their portable telescopes, the group has also built a complex of permanent observatories. Inside the enclosure housing their big 20-inch telescope, accomplished astrophotographer Alan Smallbone attaches a special astro camera to the eyepiece. He's preparing to image the Orion Nebula.
It's a very challenging object to me because it has very light areas, it has very bright areas, it has very dark areas, and it's a very difficult item to photograph accurately.
The digital cameras used by today's astrophotographers emulate color vision in the human eye itself. There are 3 kinds of cone cells on the retina, each sensitive to either blue, green, or red light. That's why those colors are considered the primary colors of light. But the retina of an astro camera is a computer chip, sensitive only to black and white. So for color photos, it uses red, green, and blue filters, taking at least 1 shot with each one. It's often called the RGB technique and is standard for producing more natural color. In capturing the Orion Nebula, Smallbone takes time exposures lasting 5 minutes through each of the 3 filters. But nebulas are so dim that for the best photos, he often needs dozens of exposures, with times totaling as much as 14 hours. No one ever said this was easy.
Astroimaging can be very tedious because it's very time-consuming. It involves long periods of time where you're sitting waiting for the camera, and the mount is just tracking, and there's really nothing you can do except sit and wait.
Later, Smallbone stacks the raw images on his computer. There, the different combinations of red, blue, and green dots work just like a color TV to create every other hue in the spectrum. Hours after first opening the shutter, the Orion Nebula appears in its natural colors on the screen, as no human eye has the sensitivity to see it. The striking images of these and other nebulas demonstrate the essential reason astrophotography is indispensable when it comes to the nebulas.
The combination of a telescope and a camera actually allows you to see details and structures in the nebulae that you couldn't see with your own eye because they're so faint and diffuse.
The Great Orion Nebula is well worth the attention it gets. 15 light years across, it is a massive cloud made mostly of hydrogen. It is the quintessential example of the kind of nebula known as a star-forming region.
It is the cradle of the most massive stars that are born in our galaxy. And it is the closest example of that process to us. So when you look at the Great Orion Nebula, you're looking at stars being born.
Among the thousands of infant stars in the Orion Nebula, 4 of them dominate. The corners of a cluster called the trapezium for its trapezoidal shape. Massive and hot, they are responsible for the brilliant astronomical display.
The trapezium in the center of the Great Orion Nebula is what energizes. It's just what makes it a nebula. If you didn't have the trapezium stars, it would be a dark cloud.
Radiation from the trapezium stars sculpts the surrounding gas and causes it to glow with emitted light. What would it be like to fly through the Orion Nebula in a spacecraft? It might look like this. A remarkably accurate supercomputer simulation based on detailed Hubble Space Telescope data and modeled by Vanderbilt University astronomer Robert Odell. Traveling into the gigantic cloud, we see the 4 bright trapezium stars, their 3D positions now clearly evident. Their intense energy has hollowed out the nebula's center. The trapezium stars are so bright that they would blind us to the rest of the nebula if our view screen were not enhanced to show us all the details. The dark globs scattered about called proplyds, or protoplanetary disks, are blankets of dust surrounding newly formed stars, forced into teardrop shapes by energetic stellar winds from the trapezium. One of them clearly shows a ring of debris orbiting its central star, strong evidence that a new system of planets is forming. Our route out of the Orion Nebula shows us the angle at which we see it from Earth. But at 1,300 light years away, it shrinks to a minor smudge in our field of view. Imagine how it would look at only 4 light years, the distance to the nearest star.
The Orion Nebula, if we were as close to the Orion Nebula as the nearest star is to us, it would be so bright that we wouldn't be aware of the dark sky. We wouldn't see the other stars. We would almost not be aware of other galaxies just because it would be so bright. Our whole world would be the Orion Nebula and the sun.
Fortunately, we live at a point in the galaxy where our telescopes and cameras can comb the heavens to shake loose the gems we call nebulas. There are 5 major kinds. Star-forming nebulas like Orion are called H2 regions. H2 describes the thin hydrogen excited by hot stars to emit light. In other places, there are reflection nebulas, where the bright stars have driven away the surrounding gas, leaving mostly dust to reflect starlight. Planetary nebulas are formed during the slow dying stages of ordinary stars and produce some of the most intriguing displays of shape and color in the galaxy. Supernova remnants are also leftovers from stellar deaths, but from massive stars which end their lives in immense explosions. And finally, there are the dark nebulas, clouds of interstellar gas and dust, visible usually because they appear in silhouette against the bright nebulas behind them. In time, stars will burst into existence within them. But the very origin of the galaxy's clouds, stars, gas, and dust is the most intriguing phenomenon of all. Springing from the mysterious interstellar medium, the riddle of the nebulas is how they can form from what is almost nothing at all. Space and its vast emptiness has much more to it than meets the eye. Filling the distances between the sun and all its galactic neighbors is the neutral interstellar medium, or ISM.
When we think about the blackness between stars, we sometimes think there's nothing there but the vacuum of space. But actually, even the so-called vacuum of space is full of dust and gas. Now, it's quite rarefied. How rarefied? Perhaps better than the best vacuum we can create on the planet Earth.
The particles in the interstellar medium are 90% hydrogen atoms, 10% helium, and trace amounts of other elements and tiny specks of dust. Existence of the gas and dust is evident by looking at the Milky Way, the band of stars we see in the edge-on view of our home galaxy from Earth. There, the dark spaces seem to be empty, but in reality, the opposite is true.
Those spaces aren't devoid of stars. They're actually dust between us and the distant stars in the plane of our galaxy, and they block that light. And you see them in silhouette.
The black lanes of gas and dust show us where the interstellar medium is clumping together to form nebulas in their most primeval form. We see these dark nebulas as shadows against the background stars. The Snake Nebula is 650 light-years distant and approximately 3 light-years across. Even darker is Barnard 68, named for Edward Emerson Barnard, the astronomer who discovered it. Such nebulas may be deep enough to block light from stars behind them, but the gas and dust inside them is still very thin. That is, until gravity's work accelerates.
Gravity is attractive. As a consequence, we have lumps of gas, no matter how rarefied, being attracted by gravity until we have clumps of nuclear material condensing. As gravity begins to compress the gas, it starts to heat up in temperature, creating the temperatures of a star.
The new stars burst into existence, lighting up their surroundings with colorful brilliance. Remaining dark nebulas stand out in stark contrast. Like bright nebulas, their shapes suggest names. The Elephant's Trunk Nebula, the Cone Nebula, and the Flame Nebula, where dark and light areas create one of the sky's most dramatic images. The brilliant colors of the star-forming regions come from nebular gases excited by invisible ultraviolet radiation from nearby hot new stars.
The light, the ultraviolet light from those stars, is stripping off the electrons in the gas in its immediate vicinity. These electrons float around for days or weeks, and then ultimately find a bare proton or other positively charged nucleus. And they'll hop onto orbits, and as they do, they'll emit light.
At the University of Rochester, astronomer Adam Frank compares the excitement of gases in a nebula to a basketball game.
This basketball game is a real nice analogy, though earthbound, for what happens in a nebula. Down on the court, you've got Rochester going up against NYU. The basketball players are a lot like the stars at the center of the nebula. When something exciting happens on the court, you see the crowd getting all excited. The crowd stands up, they cheer, they emit energy. In this case, it's sound energy, but in the nebula, it would be light. This is exactly the same thing that happens when an electron gets ripped off an atom, flies around for a while, and then finds another atom to recombine with, and emits energy at the same time.
As new stars are born within the nebulas, they sometimes shoot out spectacular jets. This one is 3 trillion miles long. The jets are nebulas in their own right, generated by the orbiting cloud of gas and dust sending material into the young star.
Because of rotation, it first forms an accretion disk, which is kind of like a frisbee spinning around the young star, building the young star. Now, there's always magnetic fields in all of this gas, and as the disk spins, material loads up onto the field lines, as we say, and it spins and then is flung out into space. Eventually, the field lines get bent around, collimating the jet, creating a nice solid jet column.
Along with stellar jets, the galaxy's nebulas display a wild variety of bubbles, shock waves, pillars, and even mountains. These are called the mountains of creation, a nebula often compared to the famous pillars of creation, but in fact, 10 times as large. Though they are 70 light years across, this image, taken in visible light, shows them subtle in appearance. But see what happens when we look at a picture from the Spitzer Space Telescope, which views them in infrared.
Infrared light is light of a slightly longer wavelength than visible light. It's redder than red light. We commonly see infrared light from objects like us that are warm, but not extremely hot.
Since infrared light is emitted by anything that is warm, it's often used to detect heat. In special cameras, each temperature is detected as an infrared color that we can't see, and then it's translated into a visible color that we can see. That's how infrared can use body heat to reveal some amateur astronomers working in the dark of night, when otherwise we'd have to turn on a light to see them at all. In space, the same principle applies. This is the Eagle Nebula as seen in visible light to the naked eye. But with telescopes in space and on Earth, their beauty is revealed. Glowing, reflecting, or obscuring the galaxy's light. They are regions where stars are born, where stars die, and where explosions wreck the very fabric of space-time.
Nebulas have
labeled with numbers from astronomical catalogs. Many also have names inspired by their locations or shapes. It's not difficult, for instance, to see why this is called the Butterfly Nebula, or this is known as the Horsehead Nebula. The list goes on.
the Orion Nebula, the Ghosthead Nebula, the Stingray Nebula, the Helix Nebula.
Called the Eagle Nebula. Nebulas of all kinds are scattered among the stars everywhere and are among the most spectacular sights in ours or any galaxy.
Nebulae are beautiful, all of them. They really strike the eye.
From the Greek word for cloud, nebulas are just that. Clouds of interstellar gas and dust, rarely visible.
Fantastic shapes like clouds in the sky on a summer day. They often evoke imagery that hits very close to home. Images of flowers, images of insects, images of people.
It's interesting when people look at nebula, it's like a Rorschach test. They sort of start seeing things in it.
Although nebulas are, it is one of the most famous space photographs ever taken. As seen by the Hubble Space Telescope, it shows the pillars of creation, massive columns of dust and gas 7 light-years long. As big as they are, the pillars are just a small part of an immense stellar nursery 6,500 light-years from Earth.